I'm so excited when I saw the theme for ng-conf this year, because I get to talk about sharks again for a bit. And so, does anyone know what this shark is?
Mako.
You know it, yeah, it's the short fin Mako, and it's the fastest shark in the world, which seems, appropriate for a talk about profiling. Because I guess you're here and you want to know how to make your applications as fast as they can be. And so hopefully in this talk, I'll be able to give you some hints, some ideas of how you might be able to, profile your own applications and make them as fast as they can be. So I'm Stephen, and I'm sure you know that I work at AG-Grid, and I'm sure you know lots about AG-Grid. But a bit more about me, I've got 4 kids and 2 dogs. Sometimes I need to profile my own household. But there we go. So these are the things. Sorry if my voice is going to go all over the place. It wasn't the karaoke, it was talking to everyone yesterday, but we're going to get through it. So we're going to talk about Angular DevTools, the Web Vitals extension, DevTools Performance Panel, and then I'm going to throw some hints in at the end if I've got time. So let's start off with the Angular DevTools. So this is a browser extension that provides debugging and profiling capabilities for your Angular applications. I'm guessing most of you have it installed. If you don't, definitely install it, because it's going to give you great insights into your Angular application. So one of the things we can do with this, once you've got it installed, you'll see an Angular tab in your Chrome DevTools. Now, if you go to the profile section of that, you can click to record a profile and then just start interacting with your application. So for me, this was with AG-Grid. And what you might have noticed is that as I was scrolling and moving around the grid, we've got thousands of change detection cycles. And this is not good, basically. So this is something that we want to fix. And this is something which the Angular DevTools has enabled us to view, just very simply. All we did was click record, interact with our grid, and this problem was immediately obvious. So then the question is, well, why is there so much change detection? And so this is when you can, once you've recorded your profile, you can start clicking on the bars, and the source will tell you, okay, what is the trigger of this? And so as I did this investigation, we had things like, there's a mouse out, or there was lots of set timeouts. And so then it was a matter of digging into the code and saying, well, where are all these timeouts coming from? And now it turns out, inside of AG-Grid, we've got a lot of asynchronous behavior going on, and that uses set timeout. So this is one of our functions, and you can see in there's this set timeout. Now, because Zone was patching the set timeout, every time this got called, we were running change detection. But the key thing to note there is that we didn't need to refresh any kind of templates at that point for every one of these timeouts. So we don't need change detection to run. So this is called zone pollution, and it's listed in the Angular docs under the profiling or the performance section. And what we can do to fix this is explicitly say via zone, we're going to run this outside of Angular. And what this means is that in this callback, if there are any kind of set timeouts or request animation frames, all of those will no longer trigger change detection. So it gives us a way of taking control of that and running our code as efficient as possible. And then maybe when we get to the end and we actually need to update templates, then we can fall back into Angular and trigger change detection. And the result of this is quite striking. So instead of thousands, we just got a few hundred. And so this grid is using Angular components in every row, which is why when you're scrolling it, we need to render those components and have change detection run. If you're just using the grid in its standard form, there doesn't actually need to be any change detection because we can render it for you. But yeah, so this is in 31.1, which has leads to some great performance improvements. But just be careful. Don't go and suddenly litter your apps with run outside of Zone.js, because any code which then maybe triggers an update or causes a template to rerun won't actually display the value. So you might be clicking a button to increment something. You can see in the console that the value of the number is going up, but your template isn't reflecting that. So if you're seeing something like that, it's because that code is running outside of Angular's zone. So if you see that happening, look in to see whether your code is, I guess, having a side effect. And if in some place you need to bring your code back inside Angular zone, then ng-zone has a run callback, and you can force things to run again in that. Another thing to look out for is not just the number of bars, but are there any really tall bars that stick out? Because this suggests that, at this point, something kind of heavy is going on. So the Angular DevTools, it will help you pinpoint this, and it will tell you which components have, run there and how long they've taken. So if you see these really tall bars, then you're going to need to look into it and dig a bit further. So is there some expensive calculations? Can you memorize them? Can you use a custom pipe? Maybe there's some large component trees that you need to refactor and break down, or use on-push change detection. And you'll probably find, I think, using signals as well, this is going to help you avoid some of these issues, because it'll be much more focused. And I definitely recommend this video from ng-conf, because he goes into all of these things and explains it really nicely about the Angular DevTools. 1 second. Right, next bit, that's better, I think. So Core Web Vitals is another really key factor in how your application performs. So these are a set of metrics devised by Google to, I guess, impact the search results in one thing, and then also just generally how good your application is behaving. So it's important that your application scores well on these factors, both just for your users' experience, but then also in terms of your search results. And the key one, which is new as of this month, is interaction to next paint. So this is all about the latency. So like when you click something or when a user types, how quickly do they see something responding to that? So a low score of this means the page responds quickly, and a high one might mean your user ends up rage clicking buttons because nothing's happening. So it's those kind of things that we want to avoid. And now an easy way of seeing these scores, in development and also as you're working, is the Web Vitals extension. So you can download this from Chrome Store and install it, and there's options to be able to toggle on this console logging. And if you do this, then you can do something like the following. So once again, I was running this on our documentation site, and I thought, okay, let me just test out this filter. And as you can see, the initial implementation of this is the text is quite jumpy, and you suddenly see all these red messages going in the console, so there's clearly an issue there. And this is because our filter text on every single keystroke was kicking off filtering. So what do we do? Well, in this case, we just simply debounced the filter, and that gave the browser an opportunity to paint. And this meant that instead of blocking the browser, you now see that the test that we're writing, every single character is printed very smoothly, the grid is filtering without blocking the browser, and we're getting these nice green console logs. So the thing I really like about this Web Vitals extension is you're not having to dive deep into the performance panel, which takes a lot more mental effort and like recording profiles. Simply add this extension, enable the console logging, and just interact with your app and just notice what's going on in the console. So it's just so much easier to do this. So definitely as a first step, give this extension a go. And if you want some more details on how to optimize this, these are 2 articles that I'd recommend reading. The second one, Mastering Interaction to Next Paint, I think this came out this week. but it's got so much detail on it. So these are definitely worth the time going through and familiarizing yourself with this new metric. Oh, God, I'll let you take a picture. Right, the Chrome DevTools performance panel. So this is when we need to go deep and detailed. There is so much information in this panel that sometimes it can feel a little bit overwhelming. But there's so much success we can have with it if we just focus on some of the sections to get started, and then we can just slowly build up, and as we get more comfortable with it, dive even deeper. So some of the things we can do here is see, well, why is one kind of method happening? How long is it taking? It will start enabling us to investigate things like forced layout issues. So it's detailed. To record a profile, open up your DevTools, go to the performance panel, click record, and then interact with your application. And what it's doing, it will record all these everything that's going on, and then you stop the profile, and you'll see this kind of view. So we've got this overview timeline, we've got some stuff in the middle, which you can't see at the moment, and then a table at the bottom, which is actually the bottom-up view, which is definitely one of my favorites. So now let's go and explore a profile. Here we go. So you can open up DevTools, and you can save a profile and load it again another time. So this is useful if you want to share performance characteristics with someone else on your team. You could record something that's happening and then send them the profile. Sometimes users have sent us profiles of their interactions with AG-Grid, and that's been really useful because we can then dive in and see exactly what took a long time. But I will say, running it against your local code with source maps makes this so much easier to use, because then when you zoom in to, say, this individual task, let's zoom in all the way, you'll get nice method names. Whereas if the file is minified, you might not be able to say, well, what is this method? I can see something's running, but you won't know what it is. So it's nice that we can see, these are the methods. So we've zoomed in, we can scroll down and see, so the row control component is setting controllers, we're creating new cell components, and we can zoom in even further, and we start seeing all these blue little dots or sections. We think, well, what is that? So then we might come in here and we'll look at this bottom-up panel. If I zoom in a bit. So we see I've sorted it by self-time. So that's a measure of how long do we actually spend inside this function. And we're spending a whopping 73% in this parse HTML function. So if we want to profile and improve the performance, then the ones that are appearing at the top here, that's what we want to deal with. And then we can drill down into this further and see, well, what's calling this and what's the code path that has led to this. So we can see it's coming from our cell component when it's setting inner HTML, then the browser is being forced to parse this HTML. So that's, I guess, an example of how I've used that panel. Let's get back into the slides. And it turns out we could make a quick fix for that. Get rid of the inner HTML, and when we're just setting text content, just set text content. And this had a massive performance win for the grid when we're rendering cells, and the FCP dropped from 534 down to 221 in version 31.1. So again, these are performance improvements which we've been able to achieve by just diving into the code, doing these profiles, and seeing where we're spending all this time. Another exciting thing which Chrome version 122 has made easier is that if you click on some of these purple boxes, so this is a recalculate style, it now will show you an arrow and link back to what triggered the change for the browser to have to recalculate the style. It doesn't look like this. I'm just highlighting it because the arrow is very small, so I don't think you'd be able to see it. And also in the summary panel, there's a tiny link which says the source, and you can click on that, And again, if you've got source maps, it will take you to the line of code which caused the style to change. And we actually had this as well in ng-grid. So new rows were added into the viewport, old rows were being destroyed, and we'd set up an animation to animate them out. And sometimes you might have loads and loads of rows. So you'd want, if a row was being animated from the top of the table, you didn't want this row to, move miles down the viewport past, hundreds of, thousands of rows. We just wanted it to animate just outside the viewport. So what would happen is, the new rows would be added, we'd set up these animations, and at that point, we'd change the DOM elements in the grid. So now when we went to query the viewport height, the browser says, well, something's changed. I'm going to have to force the layout so I can give you an accurate viewport height. So it'd force the layout to be run, and then give us the viewport height, and it slows everything down. So because we were able to see this link, we could then say, well, the new rows are added, the old rows are destroyed, and instead of recalculating the height, we just used the previous version. So because it's just an approximation for the animation speed, it's fine in this case just to take that last value, so we don't have to force the browser to recalculate the styles for us. So again, we removed that recalculation and sped everything up. And the basic thing to remember when it comes to thrashing and forced layouts is do all of your reads before you write. So make sure you've got all the values and then make your changes. Otherwise, you're going to be having to recalculate everything. Right, we've got time. So we're going to do some quick fire hints. So these might seem random, but these are all things that have helped me this year to improve the performance in different ways. So the first thing is with NX. I don't know how many of you know that if you just prefix an NX command with NX profile and then give it a file name, this will spit out a file which you can then upload into Chrome DevTools. So this is one that I created. And this will show you all of the tasks that I've run, and you can see like the dependencies, and also then maybe identify, well, okay, this is the really long performing task. So that's quite handy, especially if you've got lots and lots of dependent tasks. And then if you want to dive into things further for individual node tasks, you can run the node and give it this inspect break value, and then open up Chrome in the inspect one, and you can open the dedicated DevTools for node. So what this might look like is I'll run a command with that flag. We'll get started. On the inspect panel, we can see we can open up this dedicated DevTools. So it's already stopped the code there. We can go to the performance panel, start recording. We'll hit F5 or F8 to let the profile continue. We can see here now the task is finished. So we'll be able to go back, stop our performance recording, and now we can dive into what this node task is doing and use those same skills that we used before to identify functions that maybe we can optimize. You'll probably want to do some benchmark testing, because once you've optimized your code, you don't want the performance to then slip in the future. So there's different ways you can do this. You can monitor your page speed. You can maybe set up some benchmarking tools with v-test. So this is experimental, but it looks quite promising. But whatever way you do it, just make sure you've put some kind of procedures in place to then monitor your performance on an ongoing basis. And now this is a different one. So there's archetype attest. So you can do profiling for your types. So by using this, you can, so one of the complex types we've got in ng-grid is for your column definition. So you tell us the shape of your row data, and then the field property is able to do nested, like dot chaining down through your complex object. We had issues with recursive interfaces, which was blowing up the build time. And so using this tool, we can set up this bench, pass it our column definition, and give it a recursive type, and it would run and tell us how many instantiations occurred in that type. So using this was a great way of having feedback for putting in some recursive stops and other tweaks, and give you, I guess, concrete numbers to work against. So I could tweak the type and then see, okay, this is how many instantiations it either improved it or made it worse. So this is quite an exciting tool, which you might want to have a look at. And then the final recommendation, go to web.dev. There is so many good resources on this site. There's loads about profiling. So if you just took the time just to read through all those articles, I guarantee you that you'll learn something new, and across all aspects of web dev, which I guess is what it's for. So definitely take some time just to skim through these or dive deep, and you'll pick up something new. Oh yeah, and you could always just fall back to this. Thanks for listening.